In your book, you also mention about double ML, right? And you also call double ML WFL on steroids. If you can, in a short example, explain to people what is it, why do you call it WFL on steroids? That would be great.
Yeah, because it is like I cannot see another way of seeing double machine learning as linear regression on steroids. So I think one key thing that people don't appreciate about linear regression is that linear regression are actually two models inside one. There's actually a
Mhm.
quite neat proof of that. Like you can even see linear regression as something that people call a doubly robust model.
Mhm.
But linear regression is doing two things. The first thing that it's doing is that it's trying to predict the treatment. And why is it doing that? Why is linear regression trying to predict the treatment? Because if I have, let's say that I have randomization. If I have randomization, if my treatment is random, then by definition, the treatment is not predictable. And linear regression will try to predict the treatment and is going to say, hey, I cannot predict this. The residual of this prediction, the error of this prediction is huge. Hey, use this. This is the error of my prediction of trying to predict my treatment. Now, if the treatment is not random, then it's predictable. You can predict the treatment from the things that caused the treatment because the treatment is not random. And that's what linear regression is going to do. It's going to predict the treatment from the variables that you give it to it, and it's going to compute the error. And what this error, it has a very important meaning. What this error means is that what is left for my treatment that is random after I have accounted for all the things that I've included in my regression. So that's what regression is doing, is trying to predict the treatment and extracting the error. What is the error of predicting the treatment? Is everything that is not explained by the variables that I have. And if it's not explained, it's as if it were random once I've accounted for all those variables. So this is random variation. Another way to see this is that this is the residual of predicting the treatment is just like a version of the treatment that is random, as good as randomly assigned. Like this, you cannot predict it further. Everything that was already predicted and everything that is left is basically just random noise. So it's like a random version of a treatment that was initially non-random. This is what regression is doing. That's the gist of it. This is what regression is doing. That's what is important for regression. This is how regression controls accounts for bias in the variable. And that's enough for establishing causality, again, assuming that you can control for all the things that are causing the treatment. Now, regression is not satisfied with that. There's also another thing that regression is doing that is not necessarily, but that's very nice to have, which is also reducing variance. So regression is also predicting the y variable and extracting everything that is left. So let's say that you predict the y variable, the outcome variable from all the controls. What is left is only variation in the y variable, in the outcome variable, that is not explained by the control variables, the x variables. So now you have these two interesting pieces, which is, okay, you have a version of the treatment, which is random variation because regression already predicted everything away that was predicted of it. And you have a version of the y variable where everything that was predicted of it was excluded away. So you have these two interesting pieces. You have a version of the treatment that is ideally without bias, and you have a version of the outcome where all the variance was explained away. So ideally, all that is left in this version of in this y variable is variation due to the treatment. And what you do then is what regression does is try to predict what is left of the variation in the outcome with what is left in the variation of the treatment. And that's the causal effect it predicts. Again, assuming all the controls are accounted for. So that's what regression is doing. And if
Yeah,
you apply double machine learning, you're doing exactly the same thing, but instead of using regression to compute all those steps, you're using whatever machine learning model you're using. So that's why I call it linear regression on steroids. It's because it is like there's no other way of describing it.